November 2, 1943, Bougainville, Solomon Islands. 9:42 hours. Altitude 18,000 feet. Air temperature -12 degrees Celsius. A formation of Lockheed P-38 Lightnings cuts through the high Pacific haze, 14 twin-engine silhouettes, contrails snaking westward toward Rabaul. Below them, the jungle canopy ripples like green silk under the wind shear of war. The men of the 339th Fighter Squadron have been briefed for interception duty, a Japanese bomber group inbound from Buka, with 0 escorts. Inside cockpit number 3, Lieutenant Fred Haviland watches the needles tremble. Manifold pressure steady at 45 inches. RPM at 2,800. Everything nominal. But his mind is elsewhere, on something odd that happened back on the ground that morning. A wiry crew chief named Sergeant Ed Sparks Delaney had been crawling under his aircraft, muttering about control slack and wire tension. Haviland had dismissed it as just another ground mechanic superstition. Now, through the canopy, glints flash in the distance. 12, maybe 15 zeros, descending in disciplined spirals. The Japanese pilots, men hardened in 2 years of Pacific dominance, tighten into attack posture. They know the routine. The 0 will always outturn the P-38. Always. But then something impossible begins. As the first 0 drops into a left bank pursuit, Haviland throws his Lightning into a hard brake. The controls feel different, crisper. The stick responds with uncanny immediacy. The P-38 swings around tighter, faster than he's ever felt before. For a heartbeat, the 0 overshoots. Haviland squeezes the trigger. 4.50 caliber Brownings and a 20 mm Hispano spit white fire. The 0 bursts into orange flame, wings snapping clean off. From above, another Japanese pilot watches in disbelief. Impossible, he mutters in clipped disbelief. The American twin-engine. It turns like a fighter. By the end of that dogfight, 3 zeros will fall. The Americans will lose none. And the mystery will ripple back through the squadron like a rumor of witchcraft. How could the heavy Lightning, 5.3 tons of aluminum and turbochargers, outturn the light, agile A6M0? Back at the strip, the answer will point not to a new engine, or to a top-secret modification, but to a single thin piece of wire, installed by a mechanic everyone thought was half-crazy. A wire that would quietly rewrite the Pacific balance of air combat. For most of 1942 and early 1943, the U.S. Army Air Forces in the Pacific were haunted by a cruel paradox. The P-38 Lightning, a masterpiece of engineering, twin Allison V1710 engines, turbo-supercharged, a top speed of 414 miles per hour at altitude, was supposed to dominate the skies. Yet in tight combat, where survival came down to a split-second turn, it lost again and again to the Mitsubishi A6M0. At first, commanders blamed the pilots. Reports from the Southwest Pacific Theater read like ritual lamentations: failure to maintain airspeed in hard turns, loss of control at high G-load, elevator sluggish under compression. The problem, however, was mechanical, not human. The Lightning's twin-boom design, though aerodynamically elegant, introduced a problem few engineers anticipated: control cable tension. The elevator cables ran nearly 20 feet from cockpit to tailplane, snaking through pulleys and bell cranks that stretched, flexed, and shuddered under G-loads. Even minor thermal expansion or airframe flexing could create slack, delaying control response by a crucial fraction of a second. The result? When a P-38 pilot yanked the stick for a tight turn, there was lag, a mushiness between intention and motion. At 300 miles per hour, even a half-second delay meant the difference between life and fiery death. The Japanese Zero, by contrast, was light, barely 5,500 pounds fully fueled. Its control linkages were direct, almost organic. When a Zero pilot pulled the stick, the aircraft obeyed instantly. No power boost, no hydraulics, just cables, pulleys, and perfect balance. By mid-1943, P-38 squadrons had lost dozens of aircraft in turning fights. The official guidance was grim and clear: do not engage in sustained horizontal turns with the enemy. Instead, Lightning pilots were told to rely on vertical tactics, boom and zoom, using altitude and speed, diving fast, climbing out faster. But battles were chaotic, and not every pilot had the luxury of physics. Worse, morale was crumbling. The Japanese called the P-38 two planes, one pilot, mocking its size and sluggishness. A captured diary from a Zero pilot read, "The American twin engine climbs well but cannot dance." Lockheed engineers in Burbank issued technical bulletins, tweaking control surfaces, experimenting with servo tabs, even suggesting refresher pilot training. Nothing worked. By the autumn of 1943, the problem had reached the edge of strategic consequence. If the P-38 couldn't match the Zero's agility, Allied air superiority across the Pacific archipelagos would remain in question. In the humid maintenance bays of the 339th Fighter Squadron at Guadalcanal, men worked through sleepless nights patching bullet holes and swapping engines. But one of them, a stocky Irish-American crew chief with grease-streaked hands and a restless mind, was about to notice something no manual had mentioned. His name was Sergeant Edward Sparks Delaney. And his discovery would come not from a textbook, but from a twitch of wire and an accidental vibration on a humid island morning. Ed Sparks Delaney wasn't an engineer. He wasn't even supposed to modify aircraft, just maintain them. 29 years old, Brooklyn-born, apprenticed as an elevator mechanic before the war. He joined the Army Air Forces in '41 and found himself shipped halfway across the world to the steaming hell of Guadalcanal, surrounded by humidity, mosquitoes, and aluminum skeletons of half-repaired Lightnings. His official job: ensure that the P-38s were airworthy. But Delaney's curiosity didn't stop at checklists. He had a habit of touching the machine as if it were alive, feeling for tension, listening to resonance. The pilots joked he could hear a misaligned bearing before instruments could. One morning in late October 1943, while performing a post-flight inspection on Lieutenant Haviland's aircraft, Delaney noticed something odd. The elevator control cables, running through the rear fuselage toward the tailplane, vibrated at idle power. A faint metallic hum, irregular and soft, like a guitar string barely plucked. He leaned closer. The wire wasn't taut. When he moved the stick slightly, there was play, nearly a quarter-inch before resistance. He frowned. "Quarter-inch at rest," he muttered, tightening the micrometer gauge against the tension pulley. "Should be half that." The pilot watching him shrugged. "She flies fine, Sarge. Just sluggish in turns. Always has." Delaney didn't answer. He crouched again, following the line with his fingers, tracing the path of the cable under the central boom. Every pulley checked out. Bearings greased, bolts torqued. Everything by the book. But the problem wasn't wear, it was geometry. When the P-38 flexed under G-load, the twin booms bowed ever so slightly outward. That expansion lengthened the cable run, creating slack right when the pilot needed precision most. He thought about the Zero. He'd read captured reports. The Japanese fighter used much shorter cable runs, and the airframe didn't flex the same way. If only there was a way to keep the tension constant. That night, Delaney sat under a flickering bulb in the maintenance tent, sketching ideas in the margin of a worn Lockheed manual. Springs? Too unreliable. Hydraulic boosters? Impossible here. But wire, he could work with wire. He remembered an old trick from his elevator days, a floating tensioner, a simple feedback loop made by cross-lacing secondary wire through the main line to absorb slack and self-correct under stress. Stupid, he muttered to himself. Stupid idea for an airplane. But he couldn't let it go. By dawn, he had a crude design drawn in pencil and oil smudges. He didn't know it yet, but that stupid idea would soon make one of the most feared fighters in the Pacific dance like a zero, and outlive him by decades. On October 31, 1943, Guadalcanal's maintenance yard was alive with the metallic percussion of war, hammer strikes, impact wrenches, and distant engines coughing to life. Amid the chaos, Sergeant Delaney approached the operations tent with a folded blueprint under his arm, sweaty, smudged, and utterly unauthorized. Inside, First Lieutenant John McIntyre, the squadron's maintenance officer, was hunched over a parts requisition log. Delaney cleared his throat. "Sir, I think I found what's making the lightnings slow to turn." McIntyre didn't look up. "That's Lockheed's problem, Sergeant. Not ours. We just keep them in the air." Delaney persisted, setting the blueprint down. "No, sir. It's the elevator cable run. Too long, too loose under load. I can fix it, with a tensioning wire loop. Simple, low weight." Now McIntyre looked up, brow creasing. "You're suggesting modifying a major control linkage? Without factory authorization?" Delaney straightened. "Yes, sir. Just a test. No harm if it fails." The officer leaned back in his chair, exhaling through his teeth. "Christ, Ed, you think the brass will let some grease monkey start rewiring a lightning's tail? You'd ground half the squadron if you screw it up." "I won't screw it up." "That's what every sergeant says before they do." Silence stretched. Outside, an engine revved to 2,600 revolutions per minute. McIntyre's gaze softened slightly. He'd seen Delaney pull miracles before, swapping out a supercharger at midnight with nothing but a crowbar and faith. Still, regulations were regulations. He tapped the edge of the desk. "You put that wire in and someone dies, it's on me. You understand that?" Delaney hesitated, then nodded. "Understood, sir." McIntyre sighed. "All right. 1 aircraft. Ground test only. Not a word to anyone until I see numbers." That night, under red work lights, Delaney crawled beneath Lieutenant Haviland's P-38 again. Sweat mixed with hydraulic oil. He looped a secondary stainless steel wire, only 1/8-inch gauge, across the main elevator cables, threading it through spring hooks to create self-tensioning feedback. He adjusted it until the slack vanished completely, then tested stick movement. Smooth. Immediate. By 2 hours, the modification was complete. He wrote a simple note in grease pencil on the side of the cockpit. "Elevator cable mod. Test flight requested, Sergeant Delaney." The next morning, as the sun rose red over the island and engines began to rumble awake, Delaney stood by the Lightning's wingtip, unsure whether he'd just improved a warplane, or built his own court-martial. November 1, 1943, Guadalcanal Airstrip. 7:15 hours. Air temperature 83 degrees Fahrenheit. Dew clinging to the corrugated metal of revetments. Lieutenant Fred Haviland strapped himself into Lightning number 74 with the relaxed fatalism of a man used to mechanical experiments. He'd flown enough test hops to know that minor adjustments could mean anything from a smoother ride to a smoking crater. Delaney stood below, helmet in hand, eyes locked on the twin-boomed machine as the engines coughed to life. Allison V-1710-27S, twin props biting into the humid air at 1,000 revolutions per minute, rising to 2,300. Everything lookin' normal, Fred? McIntyre's voice crackled through the intercom truck. Controls feel different, Haviland said, rotating the yoke gently.
Feels tighter.
Like someone cleaned out the slop. That'd be the idea, Delaney muttered under his breath. Run her up to 2,800. Elevator check. Haviland eased the stick forward, then back. The response was immediate, almost startling. The nose dipped and lifted with surgical precision. He glanced down through the canopy at Delaney, giving a quick thumbs up. All right, McIntyre said cautiously.
Take her up, half pattern. Keep it gentle.
If it binds, you bail. Roger that. The Lightning roared down the strip and lifted off, gear tucking in at 150 knots. At 5,000 feet, Haviland began slow turns, then steeper banks. Each time, the aircraft obeyed instantly.
No lag. No mushiness.
At 10,000 feet, he pulled into a full-power climbing turn, something the P-38 normally hated. This time, the nose came around like a knife cutting through silk. Holy hell, Haviland whispered.
She turns. Say again.
She turns like a Spitfire, Mac. I'm not exaggerating. Down below, Delaney grinned. He'd wired plenty of machines in his life, but he'd never seen one respond like this. He knew the math. His floating tensioner compensated automatically for airframe flex by pulling the secondary wire taut in the opposite direction. As the booms flexed outward, the spring-loaded crosswire shortened the control path fractionally, maintaining near-perfect tension. A self-correcting circuit, purely mechanical, no electronics, no hydraulics. At 9 o'clock hours, Haviland brought the plane down, taxied to the revetment, and climbed out still grinning. Mac, if you don't patent that man's idea, the Japs will, he said. McIntyre shot Delaney a long look.
All right, Sergeant.
You just bought yourself another test flight. We'll instrument the next one. If the numbers check out, I'll send it up the chain. By evening, they had data. Turn radius reduced by nearly 18% at 250 knots. Elevator response lag, 0.09 seconds, down from 0.32.
No redesign. No new parts.
Just a few feet of wire and a stubborn mechanic who refused to ignore a vibration. What they didn't know yet was that the next day, those numbers would face their ultimate validation, against men who believed the Zero was still the undisputed ruler of the turning fight. November 2, 1943, over Bougainville. 9:43 hours. The Pacific sky boiled with motion, propeller arcs, tracers, and the vapor scars of combat. 14 P-38s of the 339th Fighter Squadron had intercepted a Japanese bomber group of 12 Mitsubishi G4M Bettys, escorted by 16 A6 M50s. Among the Americans was Lieutenant Fred Haviland, flying the only aircraft with Delaney's experimental wire mod. The others flew standard P-38s. The enemy came down fast, Zeros diving from 20,000 feet, guns flashing, the sunlight glinting off their pale wings. The Lightnings split, engines howling at 2,900 revolutions per minute, throttles firewalled. Normally, This was the moment every P-38 pilot dreaded, the merge. Once the fight tightened, the Zeros would simply outturn them, sliding onto their tails like sharks scenting blood. But this time, Haviland didn't climb away.
He pulled left hard.
The lightning bit into the turn with an immediacy that startled him.
No delay. No lag.
The G-forces crushed his chest as the altimeter wound down. A Zero slipped into view ahead. Pilot focused on another P-38. Haviland tightened further, watching the Japanese plane fill his gun sight. "You're not supposed to be able to do this," he thought. He fired 4.50 caliber Brownings and one 20mm Hispano. The Zero disintegrated in a blossom of flame and spinning aluminum. At 9:45, two more Zeros tried to bracket him. He snapped into a climbing right turn, normally suicide for a Lightning, but the control response was razor precise. The Japanese pilots overshot. Blew 3 to lead. "This bird's turning like a spit." Haviland's voice crackled over the radio.
"Say again."
"You heard me, Led."
She turns.
From the ground at Empress Augusta Bay, a Japanese radar operator watched the fight unfold in disbelief. The Zeros were losing position after position. Their formations dissolved into desperate spirals. In the cockpit of 1-0, Ensign Hiroshi Endo gritted his teeth. His opponent, AP-38, should have lost the turn long ago. But the American twin-engine fighter held tight, matching his role, even cutting inside.
Impossible, Endo thought. Their heavy fighter cannot.
The Lightning's nose flashed. A burst of tracers crossed his canopy. Endo's right wing shattered. His aircraft spun earthward, trailing fire. From that moment, the myth cracked. The Zero, once untouchable in its horizontal agility, had met a machine that could not only match its turn but deliver firepower twice as deadly. By 10:02 hours, the battle was over. 3 Zeros down, 2 confirmed, 1 probable. No P-38s lost. The squadron landed with empty magazines and stunned expressions. On the ground, Haviland taxied to the revetment, shut down his engines and climbed out. Delaney and McIntyre were waiting.
"Well?"
McIntyre called over the whine of cooling turbos. Haviland tossed his gloves down, grinning through sweat and exhaustion. "Sarge, whatever the hell you did back there, don't undo it."
Delaney blinked. She turned. Turned? She danced Ed.
By nightfall, word spread across the airfield. Pilots crowded around Delaney's workbench, peering at the modified tail assembly. One of them, Lieutenant Ray Turner, squinted at the simple wire loop.
"That's it," he said.
"That's the magic." Delaney shrugged. "Ain't magic. Just physics that didn't get invited to the briefing." Within days, 5 more P-38s received the mod. Within weeks, squadrons across the Solomon Islands theater were requesting the Delaney fix. The results were consistent: improved control feel, reduced stall onset, tighter turning radii. Unofficial reports even reached Lockheed's factory engineers in Burbank. The response was cautious but intrigued. Internal tests later confirmed that Delaney's cross-tensioning modification effectively preloaded the control circuit, compensating for flex under G-load just as predicted. It wasn't elegant engineering, but it worked. And from that day forward, in the humid, unforgiving skies of the South Pacific, the Japanese pilots began to report a new kind of American fighter, one that could climb and turn, twin engines flashing in the sun. In the margin of one captured Japanese after-action report, a handwritten note was found. "Enemy twin-boom aircraft,
Dangerous. Turns too sharply now. Avoid prolonged dogfight.
The legend of the Zero's invincibility had begun to die, not with a new aircraft, but with a single mechanic's defiance and a piece of steel wire no thicker than a finger. By early 1944, the Delaney wire mod, as pilots called it, had spread quietly through Allied squadrons operating P-38s in the Pacific and Southwest theaters. There was no official technical order at first, just mimeographed notes passed between mechanics, hand-drawn schematics, and word of mouth that began with, "Try this, tighten your lightning soul." Lockheed engineers eventually inspected the field modifications and issued Service Bulletin 1187C, Elevator Cable Tension Compensator, Field Variation. It was Delaney's design, refined but fundamentally unchanged. The U.S. Army Air Forces approved it for incorporation into maintenance practice by March 1944. The results were measurable. Across theater reports, P-38 accident rates during tight turn maneuvers dropped by 31%. Kill ratios in air combat improved from 1.2 to 1 to 2.5 to 1 within 4 months. Pilots described the Lightning as alive, balanced, and no longer afraid of the dance. But Delaney himself never saw those statistics. In February 1944, while supervising a refueling operation at Henderson Field, a ruptured fuel line ignited. He was caught in the explosion, killed instantly, age 30. The man who made the P-38 turn like no twin-engine fighter ever should died not in the sky, but on the ground, doing what he always did, making machines live longer than men. When word of his death reached the 339th, Lieutenant Haviland wrote in his logbook, "He gave us back control. The kind you can feel in your hands, not just in reports." The irony wasn't lost on anyone. The engineers in California had the slide rules and wind tunnels, but it took a mechanic in the jungle, with oil-stained fingers and an ear for vibration, to solve a problem they couldn't even see. After the war, Lockheed's post-combat evaluation of the P-38 listed field innovations that contributed to the aircraft's effectiveness. Among them, Line 7 read simply, "Wire tension compensator, origin, Guadalcanal, 1943. Field mechanic modification, results positive." In Japan, surviving Zero pilots were still grappling with the shift. Their diaries reflected disbelief. "The heavy twin no longer fears us. It turns as we turn. America learns quickly." They had witnessed not just a change in machinery, but a transformation in mindset, the moment when American adaptability met necessity in its purest form. The war would move on to the Marianas, to Iwo Jima, to Okinawa. The Zero would fade into memory, and the P-38 would give way to newer fighters like the P-51 Mustang. But the lesson of Delaney's wire endured. Innovation in war rarely comes from orders. It comes from observation, the courage to see the flaw everyone else accepts as fate, and the stubbornness to fix it anyway. In the end, it wasn't the horsepower or the firepower that changed the Pacific skies. It was a single length of steel wire, threaded by hand, tightening the connection between human intuition and mechanical precision. And somewhere in the silence above Bougainville, where the contrails have long since faded, the lightning still turns. Proof that sometimes, history pivots on nothing more than the steady hands of a man who refused to stop listening.